Question 4. Use the Chinese remainder theorem to solve the system of congruences x is congruent to 4 mod 5, x is congruent to 4 mod 11, x is congruent to 4 mod 13. The Chinese remainder theorem applies to any system of congruences where all of the n1 to nk numbers are co-prime. A1 to AK can be any integers at all. And if m is the product, n1 multiplied by all the way down as far as nk, then there is a unique solution modulo m, and it's given by x is congruent to this number here, where these A1 to AK values come from the system of congruences. Each of the capital M1 to MK numbers are given by, as you see there, M1 is capital M divided by N1, as far as MK is equal to capital M divided by NK. And then each of the Y values satisfies the type of congruence you see there. So Y1 is congruent to M1 inverse mod N1 and so on. In our case, let's check that the Chinese remainder theorem is valid. Well, in our system of congruences, we can see that 5, 11, and 13 are indeed co-prime. So there will be a unique solution to this system of congruences mod this number here, 5 multiplied by 11 multiplied by 13 is 715. What we need to do is to find the values of y1, y2, and y3, and they are going to depend upon these three values here, the capital M1, M2, and M3, and we see we've calculated them already. So M1 is, well, 715 divided by 5, which is just 11 times 13, 143. M2 is 5 times 13 is 65. And M3 is 5 times 11 is 55. So Y1, according to the Chinese remainder theorem, is congruent to M1 mod N1, therefore M1 inverse, congruent to 143 inverse mod 5. And mod 5 divides into 140. So that's congruent to 3 inverse mod 5. And it's not too hard to see that that is congruent to 2 mod 5. Because 2 multiplied by 3 equals 6 is congruent to 1 mod 5. So that's one of our y values found, that y1 is equal to 2. Meanwhile, y2, according to the Chinese remainder theorem, is congruent to M2 inverse mod N2. And of course, that means in our case, 65 inverse mod 11. 11 divides into 55, so that's congruent to 10 inverse mod 11. And again, it's not too hard to see that the answer is 10 mod 11, because 10 multiplies by itself to give 100, and that really is congruent to 1 mod 11, because 11 divides into 99. Y3 is congruent to M3 inverse mod N3, which of course for us is congruent to 55 inverse mod 13. And 13 divides into 52. So that's congruent to 3 inverse mod 13. And once more, we can see an answer relatively simply. That is congruent to 9 mod 13, because 9 multiplied by 3 equals 27. That's 26 plus 1. So that is congruent to 1 mod 13. So we have the values that we need to construct our solution then. So x is congruent to a1 m1 y1 plus a2 m2 y2 plus a3 m3 y3 mod capital N. So for us, all of the a's are the same. They're all 4. M1 we found to be 143, and Y1 we found to be 2. A2 again, that's 4. M2 is 65, and Y2 is 10. A3 was again 4. M3 was 55, and Y3 was 9, and all of that was mod 715. When we calculate, we get 5,724 mod 715, but 5,724, well, that's 5,720 plus 4 mod 715, and that's congruent to 4 mod 715, because 5,720 is 8 times 715. So our overall answer then, after that calculation, is that x is congruent to 4 mod 715, which we could have predicted at the start, but that has now been confirmed by the Chinese remainder theorem.